all the important topics, all the important formulas, and we'll do some very important numericals as well, which are PYQs of what kind of question actually comes and how you can actually solve them. They will ask you every time, almost they have asked in some manner or the other, so these are very important. Okay. Hello everyone, welcome to Diksha Vedantu. This is your Aditi ma'am, and in this video we are going to revise the two chapters that we have completed, that is light and human eye. We are just going to quickly revise them, see all the important topics, all the important formulas, and we'll do some very important numericals as well, which are PYQs, most repeated questions, so you get the hint of what kind of question actually comes and how you can actually solve them. Okay, the method I use to solve the questions is very unique. It has been helpful for all the kids, and you are going to see that in just a few minutes. Okay, so watch the video till the end. Okay, let's start with the revision of very first chapter, that is light. Now, one of the most important topics that they will ask you directly in the exam, that is what are the laws of reflection? What are the laws of refraction? So, laws of reflection, we know angle I is always equal to angle R, and second, incident ray, reflected ray and normal all lie in the same plane. Very basic, very important laws, but they will ask you every time, almost they have asked in some manner or the other, so these are very important. Okay, then laws of refraction, incident ray, refracted ray. Now here it was reflected ray, here refracted ray and normal all lie again in the same plane. In this, the second law is different, that is sine of angle I, that is incident angle, divided by sine of angle R is always equal to constant. Okay, now these are all the theory parts. Now, one thing you have to revise is your ray diagrams. In the ray diagrams, we basically have two cases of mirrors, right? We have two mirrors. Those are concave mirror and convex mirror. That is concave mirror and convex mirror. Now, one very important thing you have to remember, in concave mirror, we have 5 cases and a 6th case. In the 5 case, the image is always real and inverted and of all same size, all sizes, and the 6th, it is virtual and erect behind the mirror. Done. For convex, we just have 2 cases, and that is all the images are virtual and erect and always diminished. Here the 6th case, it is enlarged, right? Let me write it down. Yes, enlarged. Now talking about lenses, on the other hand, we also have 2 lenses. They are just reverse of the mirrors. Look carefully. For the lenses, let me change the color. Yes, for the lenses, concave does not have 5 and 6 cases. It just have 2 cases. Concave lens has 2 cases. That in that the image is always virtual and erect and diminished. So it is similar to convex mirror. The concave lens is similar to convex mirror, and convex lens will be similar to concave mirror. 5 cases and a 6th case. 5 cases are real and inverted and all sizes of images are formed. In the 6th case, it is virtual, it is erect, and it is enlarged. Diminished is the case of concave lens. Understood? Very clear? Okay. Now, moving on, we have some very important formulas. First is your mirror formula. Simple, very basic. 1 by f, that is your focal length, is equal to 1 by v plus 1 by u. That is your image distance and object distance. Again, lens formula, almost the same, just the difference of a sign. Here it was 1 by v plus 1 by u. Here it is 1 by f equals to 1 by v minus 1 by u. Now, magnification for mirror, it is height of image by height of object. Same for lens, but in mirror it is minus v by u. In lens it is plus v by u. Understood? Next very important formula is your refractive index n/1. That means the ray is going from medium 1 into medium 2. Okay, the ray is going from medium 1 into medium 2. So, refractive index of 2 with respect to 1 will be refractive index of 2 divided by refractive index of 1 equals to, and it inversely proportional to the speed of light in that medium. So, that is V1 by V2, N2 by N1 equals to V1 by V2, and that will be equal to sine I divided by sine R. Understood? We'll do it very quickly, okay? Okay, then we have power 1 by focal length if the focal length is in meters, 100 by focal length if the focal length is in centimeters. And these are mostly the most important topics that you need to cover for numericals. One more thing that you need to remember is from the human eye, diagram of human eye is important. It has not been asked from quite a few years, but I will recommend you to just try making it 2-3 times. That's enough. Okay, its part and their function is important. You know, they'll ask you numericals, they can ask you assertion, reason question, case based question as well. So its parts and their functions are important. What is the function of cornea or iris or pupil? All those stuff you need to know. Okay, then defects, the most important topic of your human eye chapter. Myopia and hypermetropia, we have two kinds of defects. Now myopia, you can see nearby objects clearly but cannot see faraway objects clearly. To correct this, we use concave lens which has focal length in negative sign. For hypermetropia, you cannot see nearby objects clearly but can see faraway objects clearly. For its correction, we use convex lens whose focal length is positive. Understood? Less than 5 to 6 minutes. These are the most important topics that you need to revise before jumping into the questions. Okay, let's look at the questions now. So the very first question, now we will slow down a little bit, okay, because for the questions you need to be very calm. Now one thing is we write as we read. So first what you have to do, always write what is given in the question. An object 4 centimeter in size, that means the height of object is 4 centimeter. Okay, is placed at 25 centimeter in front of a concave mirror. So much information. So the object is placed at 25 centimeter. That is, object distance is equal to 25 centimeter. But there is a catch here. The object distance always have a negative sign. Okay, so it is not 25 centimeter. It is minus 25 centimeter. U is always negative. Okay. Then we are given that the mirror is concave mirror. When I say you have to write down everything, I mean literally everything, the keywords, okay, not the whole question. Now, one more thing you have to write. That is, as soon as you write the mirror or the lens, you remember and you write down if the sign of the focal length is positive or negative. For concave mirror, ma'am, I know that focal length is negative. So whatever the focal length will come, it will be a negative focal length. Okay. Now, in front of a concave mirror of focal length 15 centimeter. Now you will remember that focal length is not just 15 centimeter. It is minus 15 centimeter. Then, at what distance from the mirror should a screen be placed? So they're saying, this is my mirror. At what distance should I place a screen so that image is formed on that screen? So this distance, the screen distance from the mirror will be what? It will be image distance. So then we will write to find. What we have to find? The image distance we have to find. And I told you in the answer writing video that you have to put this question mark every time you're writing. Okay. Now, should be placed in order to obtain a sharp image. Find the nature and size of the image as well. We also have to find the nature and size of image. Done. Now let's proceed towards solution. Understood? This is how we have to start the question. This is how we have to read the question. Okay. Now let's see. I have to find V. Okay. I am given with F and I'm given with U. It is a mirror. Can I use mirror formula? Wait. What is mirror formula? Mirror formula was simply what? 1 by F equals to 1 by V plus 1 by U. Now I have F, I have U. Can I find V easily? Okay, let's find V. Now 1 by F equals to 1 by V plus 1 by U. F, we are given as minus 15 centimeter. You have to write minus 15 only. Okay, do not miss the sign. Then focal length is minus 15, U is given as minus 25. 1 by V, V is as it is, plus U is minus 25. See how I am writing the solution? That is very important. 1, and in the place of U it is minus 25, but there is also a plus here. So I'll write it in the negative. Okay, now I'll just take the LCM. This is minus, it will become this, right? Minus 25. Minus plus minus equals to minus 1 by 15. If I take this whole minus term here, it will become positive. Minus 1 by 15 plus 1 by 25 equals to 1 by V. Now this is the part where you have to revise and practice again and again for this whole year. Trust me, when we were teaching the last semester, the last year, there were lots of kids who couldn't take LCM, not because they don't know how to, but they haven't practiced. And in the board examinations, you won't get enough time to practice, okay? You don't have enough time to waste on calculation. So you have to practice. 15 and 25. LCM is 75. How do I know that? Practice. Practice, okay? Now, this is 1 by V. 15 into 5 is 75 and 1 into 5 is minus 5 because there is already a 5 here. Then plus 25 into 3 plus 1 into 3, that is this. So 1 by V comes out to be minus 2 by 75. So V comes out to be minus 75 divided by 2, and if you cut it, this will 2 3s are 6, 15 is left, and 7s are 14.5. So V comes out to be minus 37.5 centimeters. Make sure that you are seeing correctly that U is given in centimeters or meters, okay, and then write accordingly, okay. So our final answer is minus 37.5 centimeter. So we have to find, we found V, right? We also find, we didn't found, okay, nature and size of the image we also have to know. How do we do that? Okay. Let's see, magnification. Size means magnification, right? Every time they will ask you about the size, you have to find magnification, right? Now for mirror, magnification is simply minus V by U. Look carefully, minus V by U. Now V I have, let's just simply write it, minus 75 by 2. But be very careful. Here, V is already minus 75 by 2, right? Here, we have one extra sign. So this will be minus of minus 75 by 2. Understood? And U is simply 25, but U is, my friend, also negative. Okay? That is the catch here only. In light, you'll have to take care about the negative sign. That is it. Other than that, everything you will do. Just the negative sign is where you can make a mistake. Okay? So these two gets cancelled. Now, I will write it as 75. This goes in the denominator. Okay? This becomes 2 into 25. Now 25 into 3 is 75, that is 1.5. What did I miss? A negative sign. So there is a negative sign, there is a negative sign. So magnification is minus 1.5. That means height of image by height of object is also my magnification, comes out to be minus 1.5. That means height of image will be minus 1.5 of height of object. Now it is minus, that doesn't mean it's small. The minus only says that the image is below the principal axis. Below the principal axis. The negative sign says that the image is below the principal axis. Okay, so this is your size answer. And what is the nature? Now see, magnification is negative. Magnification is negative. That means the image is real and inverted. Real and inverted. If, however, the magnification is positive, the image will be virtual and erect. This is something you have to remember. Whenever the magnification is negative, the answer is real and inverted. The nature of image, whenever it's positive, the answer is virtual and erect. So this is your final answer. This is your final answer. Done. So we found V. That comes out to be minus 37.5 centimeters. We found nature, that is real and inverted. We found size, that is height of image is minus 1.5 height of object. Done. Easy, easy. You understand how we do the question. First we write what's given, then what we have to find, then see what is given and what I have to find and use the formula accordingly. For nature and size, you always have to find magnification. If you are given two variables, either F or U or V, you can find the third one. Done? Okay, let's do one more question. Now, the next question we have, okay, this is a refractive index question. So, be very careful when you look at this because lots of kids do very bad mistakes in this and it's very easy. I don't know why you guys feel so terrified of refractive index. I had a kid who's like, ma'am, refractive index, the question is so bad. Okay, let me show you how to do it in a perfect manner. Again, we'll start with given. Done. Light enters from air to glass. So, light is entering from air into the glass. Okay. So, it is traveling from air. Now, let me know refractive index of air is less than or more than glass. It is. Pause the video, comment down and come back. Okay. Done. Okay, so refractive index of air is less than glass. So refractive index of glass is more than refractive index of air. That means glass is denser and air is rarer medium. When light goes from rarer to denser, where it bends? Towards the normal, away from the normal. See, this is where you have to use your brain. This bends towards the normal. This is refracted angle, incident angle. Okay, it bends towards the normal. Done. So, light enters from air to glass having refractive index 1.5. Now, listen very carefully. When they say light enters from air to glass, that means glass is the second medium, air is the first medium. Done. Now, whenever this kind of value is given, you always have to write N21, where the light is going from where the light is entering. Okay. So, this means the refractive index of glass with respect to air is refractive index of glass with respect to air. Done. Now, its value is given as 1.5. Okay. What is the speed of light in the glass? To find, we have to find the speed of light in glass. Correct? Understood? The speed of light in vacuum is also given. So, speed of light in vacuum and speed of light in air is similar. Okay? So, this is 3 into 10 raised to power 8 meters per second. So, this is given to us. This is the given value and this we have to find. Let's move on to our solution. Okay? Now, let's move on. Let's go back to a very important formula. This formula is very, very, very important for all the refractive index topic, all the numericals. Okay. Now see, N2 by N1 equals to V1 by V2. We are also talking about refractive index and speed, right? So let's go back to our question. The question is, now I have N21, right? Let me write it down. I have N21 and I have V of, let's write it this like, I have NGA, that is refractive index of glass with respect to air. I have speed of light in air. I have to find speed of speed of light in glass. Understood? You have refractive index, it's given. You have speed of light in air, you have to find speed of light in glass. Now, this is the formula. N21 equals to N2 by N1 equals to V1 by V2. Understood? Now, let's apply this to this glass of air. Now, if NGA is here, NGA is there. So, just like N2 by N1, it will be NG divided by NA and then velocity will be V of A divided by V of G. This is velocity of light in that medium. Okay. So, this is the formula we have now. We just have to put up the values. NGA is given as 1.5. It is given as 1.5. V of A is 3 into 10 raised to power 8. And this we have to find. It's a very simple numerical. Understood now? Just a small brain you have to use. Okay. So, N of G divided by N. See, NG completely is given. It's not like NG is given or alone NA is given. Both are given. So, in this whole place, you can write 1.5 equals to V of A is given 3 into 10 raised to power 8 meter per second and V of G we have to find. Simply cross multiply. V of G comes here and this becomes 3 into 10 raised to power 8 divided by, this goes down, 1.5. Now 1.5 into 2 will be 3. How will you know that? By practicing. Okay. So 1.5, 2's are 3. So V of G equals to 2 into 10 raised to power 8 meters per second. And this, my friend, is your final answer. This is your final answer. We have to find speed of light in glass. We found speed of light in glass. Understood? Okay, let's move on to the next question. If the image formed by a spherical mirror for all positions of object placed in front of it is always erect, always diminished. Read it very carefully. Image formed by a spherical mirror. So we have a spherical mirror, we just don't know which one. For all the positions of object placed in front of it is always erect. It is always erect. Now, and diminished. Erect and diminished. Now, then what we have to say, what type of mirror is this? See, I know you must have answered. So, let me know in the comment section, slide number 12. So, answer in the comment section, slide number 12. Answer in comments. We do this very important thing. We mention the slide, okay? So, mention that, ma'am, for slide number 12. The answer is this. Which mirror? Concave or convex? Okay. When you have answered, now resume the video. How you have to do that, no matter what criteria or what procedure you used to do all this, but there is a very important approach to it on how to solve this question. First of all, you say, okay ma'am, there are two mirrors. One is concave and the other is convex. One is concave and the other is convex. Okay. Now, I know this 6 cases are there in concave. 5 of them forms real and inverted image, but 6th one forms, 5 forms real and inverted, 6th forms virtual and erect. Erect and convex mirror always forms erect image. Always forms virtual and erect image. Now you have your answer. They say for all the positions, there are no positions given. They said all the positions of object. So clearly your answer is convex mirror. Understood? Now, one more thing you can say that in here, the 6th case, the image is virtual and erect, but it's actually larger in size. Okay. But for convex mirror, it is always diminished. And what is asked in the question? Erect and diminished. Always diminished. Concave mirror forms large images as well, right? So, the answer is convex mirror. The answer will be, can I? Okay, no, I can't. Okay, yes. The answer will be convex mirror. Done? The answer will be convex mirror. Okay, let's move on to the next question we have. A convex lens forms a real and inverted image. What we do? We write given first. As soon as you see a numerical, you're like, Aditi ma'am said, write given. Okay. First, a convex lens is given. So, I will write convex lens is given. And as soon as we write lens or mirror, what do we write with it? The sign of focal length. For convex lens, see, for concave, focal length is positive, doesn't matter it's a mirror or lens. For convex, focal length is positive, doesn't matter it's a mirror or a lens. So here, focal length is positive. It is positive. Okay, great. Forms a real and inverted image. Now the image being formed is real and inverted, okay, of a needle at a distance of 50 centimeter. See, a convex lens forms a real and inverted image. Now, this is an image of a needle at a distance of 50 centimeters. So, 50 centimeter is actually the image distance, not the object distance. Read very carefully. It is 50 centimeter is the needle image distance. Now, you have to remember your ray diagrams. This is how you should know that you should remember your ray diagrams. See, this is a convex lens. Understand why I'm talking about this. This is a convex lens, okay? It has 6 cases. The first 5 forms real and inverted image. The 6th one forms virtual and erect. Now, in this, you have to know that these 5 cases where the image is formed, on the left hand side of the lens or right hand side of the lens. So, in lenses, we know that light doesn't reflect back. It goes straight. And in the 5 cases, the first 5 cases, it goes straight. It forms real and inverted image. It is written, right? It is forming real and inverted image. So, real and inverted image in first 5 cases is always being formed on right hand side. That means the image distance is positive. Understood? Let me explain again. Okay, so convex lens has 6 cases, 5 and the 6th case. In 5 cases, the image is real and inverted. In 6th case, the image is virtual and direct. In the first 5 cases where the image is real and inverted, which is the case given in the question, so it is real and inverted, in which side of the mirror the image is being formed? It always forms on the right hand side. The 6th case forms on the left hand side here, right? But this is not the 6th case we are talking about. We are talking about real and inverted case, and real and inverted forms on the right hand side. That means the V will be positive. If they were talking about the 6th case, that means V is on right hand side. Then we would have taken V as negative 50 centimeter. See, this is how you have to use your brain. Okay, great. Understood? Great. Now let's just solve this. Okay, I am giving this as a homework to you. Okay, now let me explain the question. I won't let you go like this. Okay, where is the needle placed to find? Now they're asking where is the needle placed. That means the object distance, the actual needle, right? So that is the object. So we have to find the object distance. In front of the convex lens, if the image is equal to the size of the object, if the height of image, oh, this is given. So they are saying where the object will be formed if the height of image is equal to the height of object. If the image is equal to the size of the object, also find the power. So we have to find the power, we have to find U as well. Now how will you do it? Ma'am, this feels a bit tricky. This is the simplest question ever. I'll give you a hint. Okay, this is the solution and this is a hint for everyone. Hint is, remember one case where if we place the object on center of curvature or 2f1, the image will also be formed at center of curvature or 2f1, right? So this is the case that, why? Because in that case, the height of image is always equal to height of object. And what is given in here? The height of image is always equal to height of object. That means the image distance will also be equal to the object distance. The image distance will also be equal to the object distance, but here the image distance is at right hand side, but we know object is always negative. Object distance is always negative. So V will be simply 50 centimeter, but U will be minus 50 centimeter because U is always negative. U is always negative. And since this is the case where the object is placed at center of curvature, so center of curvature is what? It's also 50 centimeter. Center of curvature or 2f1 for convex lens. This is for convex lens, and for convex lens focal length is what? Focal length is always positive. So here focal length will be also positive 50 centimeter. Now you have focal length, you have V, you have U. Now can you find the power? You had to find U. So U is, I already did U. U is minus 50 centimeter. Don't write 50 centimeter. Minus is very important. Okay. And focal length we found. Power is simply 1 by F. Right? Correct? Wrong. Power is 1 by F when the F is in meters. Here what? It is in centimeters. So power is not 1 by F. It is 100 by F when the power is centimeters. So that is be 100 by 50. I did the whole question. So power is simply 2 diopter. Okay. Okay, let's move on to the next question. A question from human eye, and they are going to be very tricky. Let me tell you. Let's do this. First, what is given? They are given. I've done this question in my one shot as well. So if you haven't, you want to revise, go watch the one shot, go watch the 30 minutes video. And if you are done with those, then let's do the numericals. The near point of the eye of a person is 50 centimeter. Now, calm down, stop. Okay, every time from human eye, every time whenever a question is given that the near point of eye, the far point of eye is 50 centimeter, 75 centimeter, 80 centimeter, all those cases, the new near point, this value, the near point or the far point will always be your V. That is your image distance. It will always be your V and it will always be negative. I have explained you why it is always negative. So go check the video out. But here we'll do it quickly. So V is always negative. You just imprint it in your brain. Because these questions can be very tricky if you don't remember this detail. Okay? Now we have to find the nature and position, nature and power of the lens, of the corrective lens required by the person to enable him to see clearly the objects placed at 25 centimeter. Now it clicked. Which defect are we talking about? See, his near point is shifted. His near point is went away. Near point is normally 25 centimeter. It went to 50 centimeter. That means he cannot see nearby objects clearly. That means he has hypermetropia. That means he has or she has hypermetropia. Done. Now we have to find power and nature of corrective lens. So how do we start? We start that near point is shifted. Okay, near point is also given, right? It is given that U is minus 25 centimeter. Why minus? Because U is always minus. Done. Now how do we go through this question? So solution is very simple. As you see that the near point is shifted, you understand that the person is suffering from hypermetropia. And to correct hypermetropia, which lens is used? Which lens is used? We use convex lens. We use convex lens. So the nature of the lens we found without any calculation. Now I have U, I have V, I can find the focal length, and from the focal length I can find power, just like we did in the last question. Use the lens formula here. Use the lens, let me write it. What do you have to do? Use the lens formula. Lens formula, that is 1 by F equals to 1 by V minus 1 by U. And we have V, we have U. Just find focal length, and whatever the focal length comes, power will be 100 by focal length if the focal length is in centimeters. Write the answer in the comment section. Answer in comment section. And slide number 16. Slide 16. Do you like physics a little bit now? Are you less scared of science now? When you started, you're like ray diagrams, numericals, and lots of numericals actually, and lots of information to process. But you have time, okay? We will practice this again and again. I will make sure I will come with more questions, and we'll do it again and again and again till your final board examination, okay? Do not worry. But this is something that you have to start with, okay? And this is the starting. I'm giving you a head start. You're already ahead of your peers. Okay, one more question, that is your homework now. The far point of a short-sighted person, they have given everything. The far point given is, whenever I said the far point is given, it is always V, and it is always negative, minus 1.5 meter, and it's a short-sighted person. Short-sighted person means he has myopia, because myopia means short-sightedness. Okay, so this person has myopia. Okay, find the focal length, power and nature of the remedial lens. Remedial lens means given the corrective lens. Okay, so we have to find the focal length, the power and nature of the remedial or corrective lens. Now, I know I have given in the question that the defect is short-sightedness. That means myopia. Which lens is used to correct myopia? Let me know in the comment sections again. Which lens is used to correct myopia? Great. It is concave lens. It is concave lens. And focal length of concave lens is also always negative. Done. Now, I have to find focal length, power and nature. V is given. Right? V is given. Now, one very important thing is the point where all of you might stuck. See, the far point of a short-sighted person is now 1.5 meters. You are a normal human being. What is the far point of a normal human being? It is infinity. That means any object that is at infinity, the person will not be able to see. He will only be able to see the far point, that is 1.5 meter. That means your corrective lens will make the image of the object that is at infinity. It will make the image once at 1.5 meters. Then my human eye lens will make it on my retina. So in here, u is always my infinity. Done? Minus infinity, plus infinity, infinity doesn't matter. So in here, for the far point questions, the u will always be infinity. For near point questions, u will always be 25 centimeter negative. Done? Understood? Okay, so you just have to calculate now. U is infinity, V is given by using lens formula. Can I easily calculate 1 by F equals to 1 by V minus 1 by U? And it's a very good thing about far away questions. U is always negative. This is 1 by 1.5 meters, that was in negative, 1 by focal length. So this becomes 0. 1 by infinity is equal to 0. Okay, so this is 0. Minus 1.5 equals to 1 by focal length. So focal length simply comes out to be minus 1.5 meters. And we have to find power. So power is, now remember focal length is in meters. So now 1 by F, not 100 by F, 1 by F, 1.5, that is minus. That is minus 10 by 15, that is 2 by 3, that is 0.666, and that is 0.67 diopter. That is your power. Done? And we are done with all the questions of light of human eye. Not all the questions, I'll say, but most of the questions that will build your base. You understood everything, right? When to take focal length, how to write the answers especially, and what is the far point, near point, what are the values of far point, near point, image distance, object distance, signs. Understood? Understood? Okay, so subscribe the channel because Aditi ma'am is here. If Aditi ma'am is here, nobody can beat you in science. Okay, I'll meet you in the next video. Subscribe this channel. There's a link in the description. Go join that WhatsApp channel. That is very important because we will be coming live in few days. Okay, you can ask your doubts and you don't want to miss our lives. So hit the notification button as well. Okay, I'll meet you in the next video. Stay healthy and keep preparing, keep hustling. Okay, bye.